Today we're going to talk about factoring quadratic expressions to get a little bit more information than what we've been getting, and or to just really kind of see what is happening with the distinct parts of these quadratic functions. So if you remember back from Algebra 1 and even before that, when you factor, you have factors of a given number, they produce the product of it. So like, for example, if you have the number 20, well, the factors of 20 are 20 and 1, right? And then 10 and 2. So you have 10, 2, and then you have 20 and 1, and then you have 5 and 4. And then you can, so this factor tree represents all of the possible ways that you can multiply two numbers and get 20, right? 5 times 4, 10 times 2, and 20 times 1. So what we're doing today is not dissimilar to that. It's very similar to that. As a matter of fact, it is that. What we're going to do is to take a quadratic that's written in standard form, like ax squared plus bx plus c. And what this actually is, even though we know it as the standard form of the quadratic function, is that it is a trinomial that can be factored into two binomials. Multiplying, so this binomial times this binomial is going to get us that. So we're going to just start out with, if you remember the FOIL method, right? When we have two binomials, for example, x plus 4 and x plus 2, well, with the FOIL method, what we did was we multiplied the first numbers together, x times x, that got us x squared. And then that's the first. Then the outside, that's x times 2, so that gets us 2x. And then the inside numbers, that's 4 times x, so that gets us 4x. And then the last numbers, which are 4 and 2. So we got, in essence, x squared plus 2x plus 4x plus 8. So then what happens is we can combine these two because those are the only two like terms. So we get x squared plus 6x plus 8. So x squared plus 6x plus 8 is the product of these two binomials, x plus 4 times x plus 2. So if we took that idea, x squared plus 6x plus 8, so let's do that. We've got x squared plus 6x plus 8, and we work backward to factor this trinomial. We want to work backward to determine what the factors are of that. So to get x squared, if we think of the first one, we can use the distributive property, and then we can kind of figure it out from there. So to get x squared, well, we got x times x, right? That got us x squared. Now, the next thing I want you to think about is the factors of 8, and then when you add those two factors, you get 6. The factors of 8 are 8 and 1. Well, 8 plus 1 is 9. 8 minus 1 is 7. That's not going to get us there. 4 times 2 is going to get us there. So we've got 4, 2. Now, when I add 4 and 2 together, I get 6. And then all my signs are positive, so I'm not worried about that right now. So what I've got here then is when I go backward to factor out that trinomial, I'm going to end up with x plus 4 parentheses times x plus 2. So let's look at it then if we have an expression, x squared plus 9x plus 20. Let's think of it that way. Let's look at the factors of 20, and then we're going to find two factors of 20. When you add them together, you get positive 9. Well, we have 20 and 1. We have 10 and 2. And then we have 5 and 4. All right, 20 plus 1 is 21. That's not going to get us there. That's not either. But 5 and 4 get us there. And we know that x times x is x squared. So what do I have? I got 5 and I've got 4. And my sign is positive because I've got a plus here and a plus here. Now we might run into a little bit of a different sign a little bit later on. So when I factor out x squared plus 9x plus 20, I get x plus 5 and I get x plus 4. X plus 5, these two binomials, you multiply them together and you're going to end up getting that quadratic or that trinomial. Let's try one more here together. we've got x squared negative x squared plus 13x minus 12. Now, we can have a negative, remember, because we are going to have that parabola pointing down because that's negative 1x. So, all we've got to do then is we're still going to think of the same thing. We've got negative 12 over here on the outside, and then we've got 13 over here. So, what's going to happen here with this? We've got to factor out that negative 1. So I'm going to take that negative and put it on the outside. Over here. I'm sorry, I'm getting a little ahead of myself. So that leaves me with x squared minus 13x plus 12. So I'm going to, let me back up just a second and do it that way. So we've got negative, and then we've got inside there, we've got x squared minus 13x plus 12. Now, all right, so we've got that sort of taken care of. Now let's look at the multiples of 12. And we're going to, now that we got the sign taken care of, it's on the outside, we're going to keep it there for now. All right, so now we've got the factors of 12 are 12 and 1, 6 and 2, 4 and 3. Well, we've got negative 13 over here on the other side. So negative 13 and get a positive 12. So if I multiply 12 times 1, that's 12 positive, right? But I need to get negative in the middle here. So it's going to be negative 12 plus negative 1. That's going to get us negative 13. So here's my sign still. I've got x. And I've got x over here. And then I've got minus 12 and then minus 1. So we've got our negative on the outside. So what we've done is we've got negative x minus 1 and then negative x plus 12, and that's how we've factored it out. So that's how we can get to where we need this, and we've got the negative on the outside. So we've factored that out. All right, let's look at the factored form and work within factoring. And we'll kind of come back to some terms that we've known before. So we're going to look at this factored form of this expression. We have 6n squared plus 9n. So when we factor this out, what are we going to factor out? Well, we're going to look at the greatest common factor of these two. So greatest common factor, if you remember, so the multiples of 6 are 6 and 1, 3 and 2, right? So if you remember factoring, we looked at a factor tree like this. So we had the number 6 here, and then that was 3 and 2, right? So we could factor out 6, and then we got 3 and 2 as in our factor tree. Now, we also have another factor here that's 9. So if you remember 9, we have 3 and 3. So what is the greatest common factor here that they have in common, right? It's 3. So what we can do to factor 6n squared plus 9n is to factor out that greatest common factor. And then we also have n squared and n. So n squared is n times n, and then n is just n, right? So we can also take out an n and factor it out. So if I factor out, so this 6n squared plus 9n equals 3n parentheses 2n plus 3. So that's how we can factor that out. 6n squared plus 9n, when we found the greatest common factor of both the 3 and the n, we're able to factor 3n out and use the distributive property to get back at 6n squared plus 9n. So what if we took the same thing for 4x squared plus 20x minus 56? So we can factor out the greatest common factor of which is 4, right? So if we do a factor tree of 4, 20, and 56, we're going to find that 4 is our greatest common factor. So we're going to factor out, so we can say this. So that's going to equal to 4 parentheses x squared plus 4 times 5x, right? Because that's our 20. and then minus 4 times 14, because that's negative 56. All right, so what do we get here? We have 4 parentheses x squared, right, plus 5x minus 14. All right, so now let's keep our 4 there on the outside, and let's factor out kind of the reverse FOIL method, right? Now I've got x and x. Now I'm trying to find out what the factors of 14 are, and then where we get negative 14 but a positive 5. So if I have 14 and 1, 7 and 2, there we go, 7 and 2. So if I have a positive 7 and a negative 2, then that's going to get us what we need. So we end up with 4, and then x plus 7, x minus 2 when we factor that out. All right, so what if we have to factor ax squared plus bx plus c when the absolute value of a is not equal to 1? So if we have 2x squared plus 11x plus 12, well, we don't have any common factors, right, for 2, 11, and 12 that are common factors. That 11 kind of throws that off. But since both b and a and c are positive, let's find the positive factors of 24 that when you add them together, we're going to get 11. So we've got 24 and 1. We've got 2 and 12. We've got 3 times a, that's 24, and then we've got 4 and 6. So we're looking for that magic number 11, so that's going to get us that magic number 11, right? So then we've got 2x squared plus 11x plus 12. We've thought this through, so we're going to write that, let's write that out with our multiple there, 3 and 8. So we've got 2x squared plus, there's my 3, 3x plus, there's my 8, 8x plus 12. Now, what are we going to do? We're just going to go, we're going to factor out that x. We're going to find the common factor for the first 2 terms, okay? These are the first 2 terms. So we've got to factor x squared, 2 and 3, we don't have a common factor there. But of x squared and 3x, we do have a common factor there. So x is the common factor. That leaves us 2x plus 3 there. Now let's find the greatest common factor of 8 and 12. That's going to be 4. So we can say plus 4, and then 4 times 8x is going to be 2x, right? And then plus 3. 4 times 3 is 12. All right, so now we've got, we can rewrite that using the distributive property. So we've got x plus 4, right? X plus 4. And then we can combine these. 2x plus 3, right? So we've got 2x plus 3 here and here. So we're going to do that once, and then we've got our x plus 4. So we factored it out when that a value was, that absolute value of that a value was not equal to 1. So we end up with x plus 4, 2x plus 3. What about if you have what's called a perfect square trinomial? Remember, our squares are like 2 squared equal 4. This is a perfect squares. So a perfect square trinomial is a trinomial that is the square of a binomial. So, for example, x squared plus 10x plus 25, if I factor that out, I've got 25 on the outside and 10 in the middle, so that's 5 times 5, and then 5 plus 5 is 10. Easy peasy, right? So I've got x plus 5, x plus 5. So that is x plus 5 squared. That's a perfect square trinomial when you do that. So if ax squared plus bx plus c is a perfect trinomial, then ax squared and c are squares of the terms of the binomial. and they're going to be positive. All right, so let's find the perfect square trinomial. So if we factor 4x squared minus 24x plus 36, we can do this. Is the first term a perfect square? That 4, yes. So is the last term a perfect square? So 4 is a perfect square and 36 is a perfect square, right? It's 6 and 2. So what we can then say, if those two are perfect squares, then we can say 2x and then 6. Now, we know it's going to be a perfect square. Now, the middle term is twice the product of 6 and 2x, so it's going to be a negative right here. So we got minus 24, and it's going to be twice the product of 6 and 2x, 12x. That's going to be 24x. So there's a minus sign in the middle, and we're done. So if we want to check our work and do 2x minus 6 times 2x minus 6 and use FOIL or the distributive property, we're going to end up with 4x squared, right? And then that's my first. Outside is minus 12x. Inside is minus 12x. And then plus 36. So we've got 4x minus 24x plus 36. And it checks out with the FOIL method. So we can also find the difference of two squares. So the difference of two squares is going to be written like a squared minus b squared. And what that's going to equal to is a plus b, a minus b. So what if we have 25x squared minus 49, and we put that in factored form? So we can factor out, we've got a 5, so that's going to be 5x squared, right? That gets us 25x squared minus 7 squared. All right, so that gets us 5x plus 7 and then 5x minus 7. So that's the difference of those two squares. So if you want, again, to use that pattern for factoring that difference of two squares, that's going to get us there. And of course, you can go back and use the FOIL method to determine and check your work. So we got the first, we've got 5x times 5x. That's 25x squared. That's our first. 5x times negative 7. That's going to be minus 35x. And then 7 times 5x plus 35x. And then 7 times negative 7 minus 49. So these two go away. That leaves us with 25x squared minus 49, and it checks out. Your turn.